Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Oliver Drotbohm, who is currently a member of the Spring Engineering team at VMware, joins us from Dresden, Germany. Oliver Drotbohm, welcome to Maintainable.
Thanks for the invitation, Robbie. I'm glad to be here.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I think it essentially boils down to two particular aspects. The first one is understandability, so being able to understand a piece of code, a piece of software. And the other one being like if you're able to actually understand what you're looking at, then you still need modifiability of that software, right? You need to be able to kind of change it by some means and in a way that your change doesn't actually break anything in that very software. So I can think of a couple of others downstream, but ultimately it all comes back to those two, I think.
I feel like both of those things rely on some level of confidence in your, I guess as you said, maybe understandability kind of, and you have some confidence that you're going to make changes and you're hopefully not going to be breaking things or causing a problem somewhere down the road that you may or may not be aware of. But I'm assuming that most projects that you get to work with are not ones that you wrote every line of code and you have it fully in your head and remember, or even ones that you have fully written all the code in and keep this on your head. Are there other elements that help you? Like what sort of things instill confidence do you find about the nature of the code? People will talk about testing and things like that, but are there other elements that find that be helpful there?
I get the aspect of testing is quite an interesting one here because it ultimately feeds into the modifiability because of what you just said, right? Being able to have the confidence in a change that you actually make to the software. But testable code in itself has to be already written in a way that it's kind of modifiable, right? So, or it's kind of there's an interplay here, really, I think, because tests lead to modifiable code because you can then have the confidence in when you do further changes down the road, basically. Yeah, so testing is definitely an important part of all of that. What
other things might instill confidence in you? Like when you are exposed to a new project, do you feel like you have some recollection of, this helped me wrap my head around it kind of quickly? Or is it a speed thing? Or is it kind of more of this interesting subjective where you know it when you see it type of thing?
So I guess I feel confident when I look at a code base when I can find certain concepts and ideas that I'm already familiar with. That kind of, again, plays into the understandability bucket. There is Carola Lilienthal's book on sustainable software architecture. She has a chapter on that particular aspect, and she's elaborating on different approaches like chunking and hierarchization, modularity, and in particular pattern languages actually bake that understandability into the code base. So whenever you find pattern languages like the DDD building blocks, domain-driven design building blocks, and you find those in a code base, then you kind of can make assumptions on the code you find. That kind of makes you, ultimately familiar with the concepts and then with the code base that you're looking at, which then gives you this confidence in terms of, okay, I know what I'm looking at and I kind of know what I can do with it or what I much rather would not want to do with it, right? Certain constraints that are kind of already applied on the code base. Is that how you say it?
That's interesting. What was the name of that book again that you mentioned?
Sustainable Software Architecture, Carola Lilienthal. She's a German author. The book came out in German in the first place, but was later translated into English. I think it's O'Reilly.
All right. Okay, great. Include that in the show notes for everybody. I'm curious about, you talk about code being modifiable. Whether I don't know if do you tend to preface that with easy to modify or just that it's modifiable? Just do you feel like it should be easy to be or is it that software can be complicated as long as you can make modification to it?
The primary anchor here is some sort of modularity, which implies scoping. So you kind of get a feel get different levels or different scopes that you look at. You can, for example, I work with Java a lot, right? So you look at a class, and then when you feel confident to make changes to that class and not break anything, you can't have it to be part of a entangled mess of other classes or what have you, right? So you need these additional scopes around it, those all coming back to modularity.
Switching gears a little bit, I'm curious about what is your current take on the metaphor technical debt? Do you use it often day to day, or is it something you used to use and no longer, or felt like you mislabeled it, or?
I certainly see it talked about a lot. I once had a discussion with someone, and they had an interesting take on it, because we always look at technical debt at something that the team developing the software is kind of building up over time, right? But I think in that discussion, they were looking at it from the completely opposite angle. So kind of as, okay, there's the business and it needs to have some feature implemented. And the team at this certain point only has a particular level of knowledge, of insight into the problem domain, right? So it's actually the business, quote unquote, that builds up the technical depth here, because it's kind of the team agrees to, okay, we build something at this level, but that means that you have to later on pay us back with time to incorporate further learning into the code base. I guess that's like totally opposite of what everyone thinks of this about. But I found it kind of interesting to look at it that way, because often teams find themselves like doing certain things or coming to certain decisions when they implement code that then leads to what we traditionally call technical debt, because of their environment, there's the circumstances and the probably pressure to release something at a particular point in time. And then it's the team's responsibility to at some point fix this, right? And that's kind of the what we think of as debt that they incorporate in the code base. But it's actually, they actually need time for that, to do that. And that's something they have to get somewhere. So someone else has to pay them back in time to actually fix the traditional notion of technical debt.
No, that's a really interesting take on that. It's in the sense that I often, I talk with a lot of people on the podcast about it, and just in my client work that we do and with different companies, and talking with development teams that are trying to figure out how to gain some sort of time or figure out how to negotiate a conversation with, I'm air quoting, the business people or whoever is in charge of what the priorities are, what they're going to be spending the next several months working on, to advocate for time or convince them or persuade them to can we go back and revisit this, because this is causing us, slowing our process down. We had to make some concessions or compromises last year when we pushed that feature out. And there's this interesting thing where it feels like the business is forcing us to do these things, and it's their fault that they pushed it, but also, or we overestimated or underestimated how much it might take to build something. And so we had at the last minute decide, we'll come back to this someday maybe and fix this, and we'll get this out the door for today. And so it ends up being this who's responsible for it? Because I think a lot of product owners and people in air quoting, again, the business side of things are probably thinking, well, we're not asking you to take shortcuts unless it's explicit. Maybe there's those conversations no, just get it out the door really quickly. I don't care how. We don't have to worry about writing tests or whatever. I don't think that's often the decision by the business people. It just ends up being a decision that maybe developers take to get the thing out the door. So they're doing that kind of and maybe on their end, but maybe they're not necessarily planting those or being upfront about the fact that hey, we're making concessions to do this and we're going to need to come back to this. They might be just doing that and maybe not having that conversation as it's happening. So there's some context when they bring it back up again. Remember the thing 6 months ago we said we need to spend some time here? And I think that's an interesting framing around hey, we're doing this, but it's going to, are they having those early conversations? Because the conversation 6 months or 2 years down the road where we're hey, we built up all this technical debt, and the product people are I didn't ask you to write bad code. There was no conversation there around just, cut corners. Why didn't you didn't write tests for that, or you didn't do, it's not their responsibility to be advocates for the code base, but it's an interesting kind of a relationship.
I guess there's two things to it. One is that I don't think that necessarily cutting short on quality, I wouldn't qualify this as technical debt really. So because it doesn't actually pay on or stem from the lack of insight into a problem, right? That we have right now. But the other thing being that I didn't want to make this kind of a confrontational argument really, but rather just making explicit that okay, at this point in time, we have to ship something or build something for some reason. But at the same time, we don't know everything for sure yet, right? We're still learning. And that's why we put some time aside, that being kind of the depth that we accrue basically. And we have to basically work back on that later on. And then everyone's on the same page and hopefully gets that time granted to then later not fix things, quote unquote, but rather reincorporate the new learnings that we have in that area into the code base and basically shape it up, make it better.
That's fair, and thanks for clarifying that. And I think a little bit around there's like the quality thing. Yeah, I think that's important to be mindful of. And there's the other part of you're building something based off of the limited information that you have about how your software is going to be used or how they think it's going to be used and what sort of customers are going to be interacting with it. And like, well, we're going to integrate this thing with this third-party platform. Will it be the only third-party platform like that type of service offering that is like if you're setting up a payment gateway and you're going to charge credit cards through some payment, might you ever need to navigate or a possibility of integrating with another payment gateway, and you having that kind of that decision of like, do we make this abstract enough that it can work with any payment gateway, or do we just get the thing out working with the one we know we are going to need to use over the next 6 to 12 months? And then is that technical debt when you need to later like abstract it because you're going to add another thing, or is it just be like those are new features and that's going to require some refactoring, and that's maybe not what we would normally say technical debt is?
I think at any given point in time, it's a compromise between like us, like not over preparing, right? But at the same time, also not rushing to just that first idea that comes to mind, really. And yeah, it's kind of nice to get everyone on board and make this transparent, that tension basically, and then incorporate that into the process.
Hey folks, it's Robby, your friendly neighborhood podcast host. Let me cut to the chase. We've got a new sponsor, AppSignal, and they're a game changer. Do you know how dealing with errors and performance issues is like playing whack-a-mole in a dark room? AppSignal is the spotlight you've been missing. They bundle up to 6 monitoring tools into one. I'm talking error tracking, performance monitoring, host metrics, uptime monitoring, custom metrics for your application, and logging. If you're like me, I'm skeptical of any tool that promises to do everything, yet AppSignal shines through all that. AppSignal currently supports Ruby, Elixir, Python, Node.js, and if you're giving a go at one of these JavaScript front-end frameworks, you can easily integrate it into your application. And there's new language support on the roadmap. With plans starting out at a modest $23 US a month, it's a pretty sweet deal. Toss in ISO 27001 certification, GDPR, and HIPAA compliance, AppSignal is going to keep your data secure. Take a moment to set a reminder on your phone, send yourself an email, add it to your to-do list, and check out appsignal.com and snag your free trial today. Again, that's appsignal.com. Tell them that your good friend Robby from Maintainable sent you. Let's get back to our show. Something I hadn't thought about bringing up in the conversation is if you're having those conversations now with the people as you're making these decisions, one of the other elements is that I always find interesting is like in, say, 2 years from now, the conversations and decisions, the people working on those problems in 2 years might not be the same people anymore. And so they don't have that context. And so have you experienced any good scenarios where you've been on either end of those spectrums of being the people that were making the decision, and then 2 years later it felt like people could definitely understand the context behind those decisions, or coming in and having some understanding of like, why do these people that don't work here anymore make these decisions? Yeah, how have you kind of navigated that?
I guess the thing you immediately get to is architectural decision records, right? I mean, architectural sounds very technical, but it could also be something, let's say, less technical, really, that you describe that way. And they are a nice way to actually write down the problem and like which alternatives you've considered. Often the most important part of them is to describe why you have basically not chosen other options that were available, but you didn't end up choosing. Yeah, and I mean, so if you really have projects in which you have like people joining the team or leaving the team regularly, or consultancy engagements, then there's no other way than actually documenting these decisions on that level of abstraction for the new people to join or joining, then actually to read up on.
I'm really curious, like for all those listening, have you ever written and or reviewed someone else's like documentation of their design decisions before? Are you doing that? Admittedly, I haven't done that very much. And I wonder if that's because I live in the consultancy world where I kind of come in for a short period of time and need to make modifications to something that was already done, and very rarely often get to see that kind of stuff. It's not like seemingly easy to find, or I don't have access to it or something. So it doesn't always end up being the case, but I'm always curious about what that would look like. And I mean, I guess I've done it to some degree when I've kind of weighed up different options that we could make on a thing, but I don't know if that decision ends up getting captured and referenced much more in the future.
There's architectural templates like Arc42, for example, right, that give you a kind of a structured guide of like what to document, really, different kind of views on a piece of software in, I think, ASCII doc format or Word document templates. But like documents in architecture decision records, you actually have the notion of like one record superseding the other. So you kind of have a chain in case like a decision changes, then you can basically supersede a former decision. With documents, of course, you always run into the risk of them being outdated, and then you get a pile of sheets to actually read. But in how far that has anything to do with the software you're looking at is basically the follow-up question then, right?
So another topic that I was looking forward to speaking with you about is the challenge that teams have in building the right thing versus building the thing well. What's your take on striking a healthy balance there?
I've noticed that some people kind of see them as like opposite ends of a spectrum or a dichotomy to some degree. And I don't really think that's true, because we know that like trying to build the right thing involves iteration. So we have to be able to learn, get feedback, build something, get feedback, and then change the thing that we're building. And how else could you actually change or have a piece of software be changeable other than kind of doing it right, quote unquote? I mean, that's an ideal really, but what I'm trying to get to is that unless you apply like code quality practices on the thing you're building the thing right, quote unquote, you don't actually get to a piece of software that you can actually shape and change to become the right thing to be built, right? So
another topic that I was curious to speak with you about is I know that you're working on a number of projects that you're involved with, say JMolecules and Moduliths. So for those of us who are not familiar with it, I'm assuming those are kind of Java-related tools. What does this particular open source, these projects offer to Spring developers?
One of the two is specific to the Spring, but let me start with JMolecules first, because that in fact is not, or well, it itself is, but it's kind of, it exists in a broader context. So a couple of conference colleagues of mine, we were kind of basically discussing the chunking and pattern languages things that I've mentioned before that were like described in Carola's book, and also are part of the domain-driven design concept, right? The domain-driven design building blocks, stuff like entities, aggregates, value objects, these kind of design elements, and how we could actually allow developers to express those in code, totally independent of the language they're working in the first place. And there's an umbrella project called XMolecules that's basically trying to achieve that. It has language-specific sub-projects that provide language-specific means in Java, that's annotations and interfaces, so that you can bake those concepts into your code base. And I mean, there's not much like technical excellence in there, really. Like nothing really fancy, but just rather fundamental abstractions, but they serve quite a few purposes. Like one is the understandability aspect that I've like mentioned before, because if you can now look at a class, for example, and see that it's an aggregate root just by reading the code, you get what we call like conceptual gravity, right? So you look at that class only and you already understand its role within the overall arrangement, right? And there's also like design constraints that class probably has to adhere to at some point. Whereas without these abstractions in the code, you kind of have to find other classes, to go too much into the DDD specifics here already, but you have to like look at multiple other classes to understand the role of the class you've been looking at in the first place. So you get that understandability of the code. And what's then attached to that is like integration in certain technologies within the corresponding ecosystems that basically evaluate the concepts in the code base and then can do certain technical things with it. They can generate persistence metadata, for example, automatically, because if something is an aggregate, it has to be persisted and materialized in a certain way. But that's kind of like a downstream thing of JMolecules, but available for it as well. There's currently .NET and PHP ports for that. I haven't seen anything for Ruby, unfortunately, yet, but it's kind of a question of like who's interested in stuff like that. And then because I'm working primarily in the Java space.
Interesting. Yeah. I'll definitely include links to, you said that XMolecules is kind of like the umbrella project, and then there's a handful of languages that have some implementations of that, like kind of patterns and things like that. That sounds neat. Tell us a little bit about Moduliths.
Spring is an application framework in the Java space, pretty like widely used, pretty ubiquitous, especially in the enterprise. We have seen people building all kinds of applications with it. I probably have to mentioned that I'm part of the engineering team at VMware that builds this Spring framework. And there's been a trend to microservices recently, right? Building individual systems to decompose a system, like an overall system, into multiple ones. And like a couple of years ago, there's been some kind of backlash on it where people were like finding out that building microservices is a complex effort and it might not be worth the complexity in certain scenarios, right? And we're not really taking a stance here in what you should build, but rather would like to provide you with guidance on how to structure a system that's rather of monolithic nature. There's a couple of projects within the Spring ecosystem that deal with all the challenges and complexities that you face when you build microservices, the Spring Cloud projects. And Spring Modulithic is kind of, it's not an answer, but it's basically the equivalent to that in the monolithic world. So it kind of gives advice on how to structure your application. It's fundamentally domain driven. Most of the like technical frameworks, I know Rails is structured similarly, and also Spring Framework, they usually impose a rather technical structure on application code, which is understandable from the framework's perspective because that's what the framework is interested in. But it doesn't actually, or it sometimes subverts the idea of modularity, because especially in the Java world, there's some certain visibility means that you have in the language that you can basically make certain parts of your code base visible to other parts of the code base. And if you structure those along technical lines, then the domains, or you rather create a kind of entangled mess of code, really. And it's you're not creating a mess in the first place, but it's very easy to create one, right? Because everything is just visible to everything else, kind of, roughly speaking. And what Modulith does is, for one, it has an opinion on how to structure your code along the lines of your business, like domains, basically, your functional separation. And it then has also an opinion on how to integrate those individual parts again, because in monoliths you usually call methods on other classes, right? And module boundaries are not the best places to do that. And there's like an event-based mechanism built into Spring Modulith that allows you to integrate those modules via events, and a bit of technology that then solves downstream problems that result from that arrangement. So basically a Spring consultant in a box, quote unquote. So someone who really knows the framework in and out and knows how to, or basically has recommendations baked in of what we typically recommend people to do anyway. But there's a bit of code that you, for example, can verify the structure of your application using a test, right? And that kind of stuff. So a bit of a higher level guide on architectural recommendations for Spring applications.
Nice. And so just to make sure I'm understanding, so it's in kind of it's not necessarily helping focus around like how to best integrate with multiple microservices, but how to get some of the benefits of what microservices kind of, I wouldn't say promise, but kind of gave us this idea that if we take advantage of microservices, we can kind of separate these different things out and then only kind of decouple the thing. So this Modulith is like how to do that within the concept of your monolith, but you're still breaking things down and able to work on these bite-sized or microservices in kind of a way, but within the context of the whole thing, rather than needing to worry about deploying everything separately. And
that's exactly right. So just to give you an example, right? You have an e-commerce application. It has an order part that basically accept orders, and you have an inventory that keeps track of the stock of the products that are still available. You could build this, and we've seen a lot of teams basically building this as microservices or one of the reasons that we've heard was we would want to test these individual parts of the system independently, right? And when you build the system as microservices, you can actually do that. And we found ourselves like not actually giving any guidance on how you could actually do that within a monolith, because you of course can still like run parts of the application. Just because it's a monolithic application, it doesn't mean you have to always run everything at once, right? And there's like technical support now baked into this, which for which we previously basically just recommended, place your code or arrange your code in that way, and then you can do this. And there's now basic more technical support for that. So we've been looking at what are the goals that people want to achieve with microservices? And some of them we can't really solve in a monolithic arrangement, right? You can't necessarily choose different technology for one service versus the other if you're in a monolithic arrangement. That doesn't work. You can't really scale like one part of the system very differently than another service, basically. If in a microservice arrangement, you can't do that in a monolithic arrangement. I mean, you could still like put a lot of caching in front of the product catalog, for example. That would still give you different performance characteristics for that part. But there's certain limitations to some of the aspects that people try to solve with microservices. Others actually can be solved in a monolithic arrangement. They just have to be achieved in a different way. And we've been looking at those different trade-offs and ways we could support developers that ultimately they can choose whichever architectural style they want based on their actual like scaling organizational requirements. But they shouldn't have to start with microservices just because they want to test a part of the system individually. That's for sure.
I'm curious about how often does this sort of stuff come up within the context of where at VMware, and you don't need to talk about all their projects necessarily, but has this been like a thing that you've seen come up with within VMware, or more like VMware's customers are struggling with some of this, and some of the work that you're doing is kind of helping VMware type customers, or is this actually kind of more central to helping VMware's own tooling, or a bit of both?
It's indeed a bit of both. So like we're kind of located, or the team that I'm working is located at the most upper end of the stack of what VMware provides, right? So we're kind of building software that other people use to write software and then run it on whatever VMware or cloud infrastructure they want to have. So we're working with customers primarily that then actually build actual software and see what they want to do. But at the same time, a lot of the products of VMware internally are built with Spring as well. So there's this kind of natural relationship that we then work with these guys and give them recommendations how to build certain things and get feedback from them, what they're trying to do, what they're trying to achieve, and see what we can incorporate into the framework to make things easier for them. But for them, there's no real difference in quality, so that we would prefer like one kind of feedback over the other. It's definitely inside and outside feedback we get.
We'll be back with our interview with Oliver in just a moment. Hi, it's me, Robby. Yep, it's me, Robby. Yep, it's me, Robby. It's me, Robby. I just want to take a quick moment to say thank you for listening to the Maintainable Software Podcast. If you're finding these conversations valuable, stop everything right now. Head over to your text messages and tell your friends and families in one huge group text, you gotta listen to the Maintainable Software Podcast. It will change your life. Your life will be changed. All caps, and see what happens. You can take a screenshot of the following responses. People are asking, like, who the heck is Robby? What's Apple Podcast? What's going on? Is something wrong with you? Who stole your phone? Whose number is this? I don't know you anymore. You're gonna start losing friends. Your family's gonna disown you. Maybe don't do that. Maybe do it. I don't know. Anyhow, you can also maybe hop over to social media or hop over to Apple Podcasts and write a review. I would appreciate it. Do you know anyone I should speak with on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm. And now let's just get back to our interview with Oliver Drotbohm. So I know that you have a book coming out later this year titled Modulithic Applications with Spring. So knowing that it's, I'm assuming for Java primarily, probably in the examples and everything, but what's the kind of your target audience for that? Is that just any developers working with Java Spring, or?
It's primarily kind of a summary of all the things that we've discussed today, and that I'm usually like giving away in talks and presentations or in customer engagements. And it's of course, because that's kind of the projects I see most, targeted towards Spring and how to leverage it to build modulithic applications. That said, I think there's like, especially the first part of it is rather in not theoretic nature. I wouldn't call it, but it's evaluating the trade-offs between, if you build microservices, you get this trade-off, and if you build a monolithic application, you get that kind of trade-off. And the stuff in there should generally be transferable to other ecosystems, other programming language. Although, of course, the code samples are using Spring Modulith and using Java-based technology here. But maybe it's kind of inspiring, like the .NET world or the Ruby world, to come up with something similar, really.
Is it available for pre-order at this point?
There is a leanpub.com/MAWS for modulithic applications with Spring. I'm expecting it to be very late of this year, but you can definitely sign up to get notified once it's available.
Excellent. Is this your first book that you've worked on, or?
I've written one on Spring Data with O'Reilly, I think a decade ago or something. So it's been a while.
How relevant do you feel like that book is now?
The concepts described in there are still very valid, but like, I mean, a decade is kind of a world in technology, right? So all the code samples in there, I guess they all would still work. They're just not an idiomatic way of using Spring anymore.
Yeah, the writing books about technical things that are moving targets, it's a little bit of a challenge. My own experience was I got a book deal once upon a time with O'Reilly, and Rails was not even a year old. And 6 months into my book, I'm like, I have to rewrite like all the code samples and it's all changing. 1.0 wasn't even out yet. So I don't know what I was thinking. That was a wild ride. But yeah, that's a challenging thing. But out of curiosity, how did you decide to move into the world of feeling like you were the right type of person to write a book about something that well, it sounds like you're pretty you know a lot about Modulithic, sounds like. So you give talks a lot. So what were some of those initial seeds that you had or you noticed in yourself? So I'm assuming maybe some people listening might be thinking, maybe I could write a book one day. I don't know, but then they might be doubting, like, who am I to write a book about this?
I mean, to those people, if you're passionate about it, go ahead, write a book, right? Also have to say it's not going to make you a millionaire, but it's definitely an interesting experience. For this book in particular, my work has always been kind of centered around the idea of making architectural concepts and ideas accessible to developers, which means thinking about how to come up with programming models that, for example, it started all with Spring Data, and is very central to that is the repository abstraction of the domain-driven design book. So we started to just build code for people to access data through the repository pattern. And my work on Spring Modulith has kind of been driven by the same ideas, right? There's like the concept of a module. How can you express that in code? What does that enable you to do ultimately? And that's kind of where the focus of my work basically comes from. And that kind of then is reflected into the book, because I've given so many talks on different aspects that are now reflected in the book. And there's never been a kind of this overall kind of the thing that basically summarizes all of them, and because they often related to each other, and one thing enables the other, right? That's kind of it's been the idea. And then it's been just like I've been talking to people and they constantly told me, you have to write this up sometime. And that's what I've been doing for like a couple of years now. So it's not that I basically decided in January, I'm going to write a book, and then 2 months later I'm done. It's kind of a longer term project, fortunately and unfortunately at the same time.
Thanks for sharing a little bit about how your personal journey into that and what you're kind of focused your work on. I'm curious about in your day-to-day work at this point in your career, how much of your day are you working on coding, on project type code versus reviewing or looking at other people's code or thinking about how to improve the experience for software developers that are working with the code? Like what's that kind of ratio look like these days for you?
I still spend a lot of time on activities that I roughly describe as coding. I can't really tell how much of it is writing code, but definitely a lot of reading code, reading other people's code, but that's kind of a feedback loop anyway, right? I'm fortunate enough having stayed an individual contributor, as the company calls it, right? I'm officially like employed to write code and to ship software at some point. But there's of course other activities when I talk to customers, go to conferences and what have you, but it's still, I think, 2/3, 1/3 kind of ratio of actually building stuff. And how much of that then actually is writing code in its literal sense, I don't know really. But working with code is definitely still like 2/3 roundabout.
Hey, it's Robby again. Just wanted to quickly let you know that we have a newsletter that you can sign up for. If you head over to maintainable.fm and pop over to the newsletter tab, I think there's a link there. It says newsletter. You give me your name and your email address. You'll get emails when there's new episodes coming out. And every other week, I'm going to tell you about an older episode that you may not have listened to before. Or maybe a couple of episodes that I think are worth listening to about a specific topic, like let's say documentation. And I'll reference some of the interviews that we dug into those topics. So again, maintainable.fm/newsletter. Let's get back to our interview with Oliver Drotbohm. Okay. Yeah, I'm always curious as people evolve in their career, like kind of getting a sense of like how disconnected do they feel from day to day, like coding and working on like some tickets in your ticketing system. Like I got to work on these things today versus like you advance in your career and then things get a little bit more abstract and fuzzy around like, well, I'm actually thinking more about what the team's going to be working on or giving them, answering questions or maybe making recommendations. And that's still contributing it's just not quite the same as it was earlier on in your career where you're kind of sitting in front of your editor most of the day.
I guess what plays into this is that working in open source, like all this, what other people might perceive as like extra work, or basically this ticketing stuff or communicating with others, that's kind of like baked into the kind of product development experience in open source software development. So that's why I don't really consider this separate from the actual development, really. We create a ticket, then file a bug, write a test, whatever. It's all kind of part of actually building something, right? That might be a difference here.
It's a good distinction there. And it's funny because even working on my own open source projects from time to time, there's a certain element of like, all right, I'm reviewing a lot of people's code, but then I'm like, well, am I really contributing that much? But I'm like, I'm helping curate what gets accepted and merged, and I give people feedback. I'm like, Warren, this isn't ready until we get these other things done. Don't forget to update the documentation, whatever the back and forth conversation. So I'm still playing a role in it, but it feels very different than when I was like working on the first releases of the project, when I was like, I had the idea and I was like, oh, I got to build this feature because I want to build this thing. And now it's like, mostly become more reactive, and rather than feeling like I'm proactively planning the future of the project, I'm responding to how people are actually using it day to day. And that's different, I suppose.
Because we're not like, there's no engineering and, for example, a documentation department with us, right? So because we write software that other software developers use, which means that I am actually able to write documentation in a way, or it's easier to write documentation in a way because I'm writing to myself, quote unquote, right? So there's not that big of a difference in the audience. Whereas if you have end users, then I guess you'd need a different kind of writing style. You write about different things or other things. And that's why everything, even the non-programming activities, are much closer to the actual programming activities. And that's why it's kind of like, it feels like just a whole thing, really, and end-to-end story.
I'm curious, do you remember the first time, or what the first project was that you had, like open source project that you had something get accepted and merged into it that you contributed to?
I don't remember really my first external contribution. I definitely know that like the predecessor of Spring Data, of the thing that basically is now has become the persistence APIs in the Spring world, was the first real open source thing that I've worked on at my previous company. So we've done a lot of open source activities, but it was a project that we started ourselves. I think there was one contribution in the early days of Spring Framework when I was not part of the team yet, but like already making connections, and then I think something around embedded databases in support in Spring Framework. And I know I was kind of, I'm not sure if it was the first one, but for that particular thing, I was kind of like looking up to the other guys, and then really excited when Keith Donald back in the days, he said, I got the email saying, oh yeah, I just merged with you, CVS, I think, back in the days. But yeah, it's exciting. The Spring project, if you're interested, if someone is listening from the Java space, we definitely have tickets that I think have a special label that are suitable for beginners, and don't hesitate to have a look at those and maybe just contribute something tiny and get started.
That's great that the project does that. I know that it's always interesting trying to like figure out ways to provide like a pathway for people to come in and feel like they can contribute to your project, and trying to identify that. Because sometimes you're thinking, well, I could work on that myself and maybe I can get that done in a half hour, or I could just maybe let that exist and maybe someone else will pick it up and want to do it, and I can work on something a little bit more complicated for now or something. And not that it's easier necessarily, it's just maybe this is one a particular feature or bug fix that someone could do that's maybe kind of step in and do that. And I know there's a lot of advice out there like, well, you can easily contribute improving the documentation, or working on a bug fix if you can figure it out. But some of the larger frameworks could be intimidating to get to download and figure out how to like run their test suite, like however that process might look like, even know where to start, because maybe they don't feel like they understand under the hood all that much. And it sounds like maybe you've been around the Java Spring project for a long while, it sounds like. So I'm assuming it probably mirrors my own experience within the Ruby on Rails world, where there was very little documentation. I had to just read the code to figure out how things were actually working, being like, oh, this isn't doing what I think it's supposed to do. I better update the documentation. Is this a bug, or is this actually the way it's intended to work? And it's just not clearly communicated in the docs at this point in time. And so that was always a curiosity I needed to figure out. There wasn't anything to reference back in the day. So that's interesting projects that are 15, 20 years old, and you just assume that like everybody knows what they're doing in there. It's complicated too. It can be a little intimidating. So I will post a link for everybody in the show notes to whatever that label is in the Spring project. So if you're a Java developer and curious about that, we can get you over there. So a couple quick last questions for you. Is there a non-software, non-technical book that you find yourself recommending to people?
I'm reading quite a lot of those. The most recent one that I found particularly interesting is Rick Rubin's The Creative Act. I'm not sure if you've seen that.
It's literally on my desk over here.
Oh, nice. I'm a study drummer myself, and interestingly, a lot of people on the Spring engineering team are actually studied musicians. So there's always been a connection between the arts and programming that I've found interesting, and I found parallels between the work and what I do as a hobby now. So can highly recommend it. Rick is a great guy. He's worked with numerous artists, different artists. That's what I've find so remarkable about him, that versatility, and it's a nice one to check out.
Great. I'll definitely include a link to that. I think you're one of a few recent guests that have referenced that book. So you're in good company, and so I'm not surprised that name keeps coming up. And where can listeners best follow your thoughts and ruminations about software development online?
I still maintain my account on the company formerly known as Twitter. So if you find Drotbohm, Odrotbohm, unpronounceable to non-Germans. That's on Twitter. I usually copy stuff over to my Mastodon instance, which is the same, odrotbohm@chaos.social. And if in doubt, drop me an email at odrotbohm@vmware.com.
Well, it's been such a delight having you join us on Maintainable, Oliver. Thank you so much for stopping by to talk shop with us.
Thanks for the invitation, Robby.